Now let's look at what happens. Ini dia. This is the structure. This is the structure. Blur ke? Okay, good. So this is the structure, the whole lot of it. Before I go walk you through the processes, there are 4 simple process. Before I walk you through it, let's understand the purpose of beta oxidation. Apa tujuan beta oxidation? Sama macam kita lah, apa tujuan hidup. Same like us, why do we learn? Why do we need to learn this? Kenapa nak kena faham beta oxidation ni? So that you know that whenever you run slowly, whenever you walk slowly, whenever you go hiking, you know that beta oxidation happens in the body. Gitu. For instance, you want to lose weight, nak pecahkan lemak, janganlah sprint. You buatlah jogging. Bangun pagi, don't take breakfast. If you take breakfast, the body will use glucose. You just go minum air, mineral water ke apa, and then you just go for a brisk walk ataupun slow jog. The body will switch to beta oxidation. Where can they get this beta oxidation? From our adipocyte yang kita simpan tu. Simpanan lemak premium tu kan. So it will take from there. So that is where the source of fatty acid. Okay, now that fatty acid sudah masuk ke dalam matrix mitochondria. Fatty acid already goes into the matrix mitochondria. Fatty acid is already activated. What is the activated form? Acyl-CoA. The active form of beta oxidation, acyl-CoA. Now, the function of beta oxidation, number 1 is to gain energy molecules. Apa contoh energy molecules? Apakah contoh energy molecules? What are the examples of energy molecules? ATP, NADH, FADH2. These are all energy molecules. Beta oxidation will produce these energy molecules. Macam mana? Ada 4 steps. There are 4 steps. Number 1, oxidation. Number 2, hydration. Number 3, oxidation again. Number 4, cleavage or thiolysis. Okay? Someone would you just please type dekat chat box tu. Number 1, oxidation. Type dulu, oxidation. Number 2 is hydration. Just type hydration. Number 3, oxidation again. And number 4, cleavage or thiolysis. Boleh type nota while kita discuss tak ada masalah. I'm okay with it. Because some student dia masukkan nota dalam tu kan. Okay je. You can put it in the chat box kat bawah tu. Okay. Now let's look at the process. Kita faham macam ni dulu. First of all, you have to understand the structure. Understand the structure of fatty acid CoA. Understand the structure ni ialah CoAsh. Nampak tak? This whole structure, the one that I'm labeling. I cannot draw, boleh tak draw? Tapi saya kena keluar sebab pakai Canva. When you use Canva, you cannot annotate. Let me use keluar dari Canva tu sekejap It's my draw. Red color lah. Get it bigger. Get one bigger. Okay, we're gonna start here with fatty acid CoA. If you look closely here, this is carbon alpha. And the next to it ialah beta. Carbon alpha and beta. Okay. One more time. We have 2 types of carbon kat situ kan. We have alpha carbon right here, and then we have beta carbon. That is the structure of fatty acid. Fatty acid CoA. Can you see the figure clearly? Make that one bigger. Good? Is this good? You guys can see it?
Yes, ma'am.
Okay, thank you for responding. You can also refer to the notes that I already sent Dr. Evie. So this is fatty acid CoA. First thing first, it will go through what is known as oxidation. Oxidation. Remember that oxidation. First step, oxidation. What is oxidation? There's a tip. Perhaps you already know what is oxidation. I can give you some tips. We can go as LEO. LEO means loss electron. Loss electron is oxidation. Loss electron is oxidation. Oh my God, look at my handwriting. Loss oxidation is oxidation. Loss oxidation pula. Loss electron. Loss electron oxidation. Or you can use oil rig. Oil rig. Oil rig. Oxidation is loss. Reduction is gain. You can use also LEO, loss electron oxidation, and gain electron is reduction. LEO ni singa lah, lion. Lion sound macam tu kan. Tak macam ni lion pun. So gain electron ialah reduction. Gain electron penurunan. Proses pengoksidaan dan penurunan. This pengoksidaan. Any place when you see any incident, when you encounter a loss of electron, that is oxidation. Every time an electron is lost, something will accept it. Yang ni hilang, yang ni terima. Yang ni lost electron, yang ni terima. Oxidation, reduction. Oxidation, reduction. You just imagine you are tossing something lah. You campak ni, hilang lah dia. Yang ni terima. This is reduction. Yang ni campak je, dia campak, throw that electron. This one accept. So this is reduction, this is oxidation. Beringatlah macam tu. Okay? Right. So what happens next? So here we have oxidation. Look at this structure. Look at the structure closely. Ni, you tengok structure ni, carbon, CoH, this is CoH, and then kita ada carbon alpha here, and then we have beta carbon over there, okay, and then kita ada long chain. So ini kita ada carbon, hydrogen, CH2, and so on and so forth, because this is a saturated fatty acid. CH2 sampai panjang-panjang. Let's just assume ada 18 carbon. Let's assume we have 18 carbon. Yeah, let's just assume ada 18 carbon. So what happens during the first state, this oxidation, there'll be a loss of electron. We know that. Look at the one that label right here. Sekejap saya padam ni. Selera pula. Give me 1 second. Padam ni sekejap. I will give you this video no worries. Tengok kat carbon kat sini Look at this stage and this stage. Oh my God, kuning pula. Tak apa, saya buat macam ni je lah Nampak tak sini? Ni kita ada hydrocarbon. CH2. And this part, dah tak ada. Look at the difference after oxidation. What happens here? Apa yang dia hilang kat sini? They lost hydrogen. Here kita tengok ada hydrogen. Single bond. Over here, after that oxidation, we have hydrogen and hydrogen, but we have double bond. Mana pergi hydrogen dia? Okay, remember this. Every time a molecule lost dia punya electron, dia juga akan hilang proton. Every time when a molecule lost its electron, hydrogen pun akan hilang juga. Hydrogen here, I'm referring to proton. H plus, this is proton, ion hydrogen, hydrogen ion. Every time you lost the electron, you also lost the proton because the proton tags along with electron. So sini, what happened is that during oxidation, we have loss of electron. Hydrogen juga hilang. Kemana dia pergi? Dia akan hilangkan hydrogen ni. FAD will accept that hydrogen and the electron. This one lost the electron. Here we lost the electron in fatty acyl CoA. Fatty acyl CoA, we lost the electron, but FAD will take that electron. FAD will take that electron. Now it becomes FADH2. This is the first energy molecule. The first energy molecule. You got that? Boleh? Ulang. So kita ada fatty acyl CoA. We go through oxidation. This is where the loss of hydrogen as well as loss as electron. Siapa nak terima ni? When you lost hydrogen ion, when you lost electron, who gonna accept that? Who gonna accept this? Sekejap, padam. Okay, hydrogen ion. Ni siapa nak terima? FAD. FAD terima, it will accept it, so it becomes FADH2. So that is the first molecule. That is the first stage. So apa berlaku pada fatty acyl? Nama sudah baru, dah tukar nama baru sekarang. Nama barunya ialah trans-enoyl CoA. Trans-enoyl CoA. So this is the structure with double bond right there. Okay, itu ialah oxidation. What's next? Next kita ada process of hydration. The word hydration, you ingat ni, it involve water molecules. Every time involve water molecules means, ni kena ingat kalau ada you nampak hydration, dia mesti involve of hydrogen ion as well as hydroxyl ion. Mesti involve dua ni. Okay, mesti involve dua ni. So for hydration, what happens? Just now we have this structure, right? Hydrogen. Datang daripada water molecules ni. Ada hydrogen and ada OH, hydroxyl ion. So dah jadi macam ni dah structure kita. Just now we have trans-enoyl CoA. Now we already have 1 beta hydroxy acyl CoA. Maybe these words are new to you. Maybe you haven't heard this molecule before. Tapi tak apa, jangan sedih-sedih, jangan menangis. Nanti lama-lama ingat. Revisit and then you'll be okay. So hydration, kita ada structure ni. Lepas tu apa pula? Lepas tu kita ada another oxidation. Tadi dah oxidation, ada oxidation lagi. Twice oxidation. Apa berlaku pada second oxidation? Sama juga, this structure will lost dia punya electron. Dia juga akan lost dia punya proton. Aduh, siapa nak terima ni? Kita ada NAD+. They will accept this from hydroxyacetyl CoA ni. They will accept the electron. It will accept the hydrogen ion. So apa berlaku? Dia akan jadi NADH and H+. Ini apa? The second energy molecule. Okay. Now let's look at the structure. From this structure to that structure. Oh, dah berubah lah. Dia sekarang ada O kat sini, oxygen. Because the oxygens come from air. This one originate from air tau, from water molecules. If you recall this one, ni datang daripada originate from water molecules. Remember kat sini? I like this gambar rajah because it clearly shows where the carbon, hydrogen, oxygen comes from. So you know this one is water molecule, it comes from water molecule right here. So now that we know this oxygen comes from water molecule. So kat sini, if you look at the structure, we already have, we don't have full hydrogen kat sini. Kita hydrogen hydrogen pula. Carbon, hydrogen, hydrogen, and then kita ada carbon, dia ada double bond oxygen kat sini. So that is known as ketoacyl. This is ketone. Ketoacyl-CoA. Structure different, the formulation different, arrangement of molecule different. So what's next? The next one ialah, now that we already have two kan, kita ada FADH2, we have NADH. The next one is cleavage. Cleavage or the process of thiolysis. T-H-Y-O, thiolysis. Thiolysis is where we are going to cut it, cleave it, to cleave this beta ketoacyl-CoA. Before we do that, we're going to cut it to carbon. So kat mana? Sekejap saya padam ya, serabut semua ni. Look messy here. Let me give it cuci sikit. Erase. So kat mana? Di sini. We're gonna cut here. That is known as cleavage. You cut. Cleave it. So what happened to this part? Inilah dinamakan acetyl-CoA. The one that we cut just now in between here, this remaining part, these are all known as acetyl-CoA. So what happened to acetyl-CoA? Dia boleh terus masuk ke citric acid cycle. What happened to FADH2? It can go into electron transport chain. What happened to NADH? It will go to electron transport chain to produce more energy, to produce ATP. It go to ETC or electron transport chain or electron transport system to produce more of ATP. This one as well, you can go to the electron transport chain or electron transport system to produce more ATP. Okay, what happened to acetyl-CoA? It can go to citric acid cycle, or you call it TCA, Krebs cycle, to produce more energy. So what happens to the one that the remaining? Tadi kalau if you recall, kita potong kat sini kan? We cut it here. At this line. Sini. We cleave here. Dia jadi acetyl-CoA. What happened to the remaining? This remaining still have long carbon. Apa yang akan berlaku ialah it will be shortened. Okay, it will be shortened. But it requires CoAsh. Kat sini, if you look, it's already shortened. If the initial is 18, tadi saya kata, just imagine ni 18 lah, contoh 18 carbon So ini dah 2 carbon, the remaining should be 16 carbon. Dia akan jadi 16 carbon. Fatty acids, just imagine ada 18 carbon, just imagine je, 18 carbon. First round, beta oxidation, it cleave 2 carbon. 18 potong 2. Jadi acetyl-CoA. Remaining ada 16 carbon. The 16 carbon later on will bind to CoAsh. Combine dengan CoAsh ni. So it become new fatty acid. But this fatty acid only have 16 carbon. That 16 carbon will go through again the cycle. Pergi pusing lagi cycle tu. From 16, cleave another 2. 14 carbon. And then go ahead around more, one more round. Round lagi. Because dia akan round benda ni kan. Pusing lagi. 14, potong lagi 2. Tinggallah 12 carbon. 12 carbon fatty acid. Pusing lagi. Potong 2 carbon lagi. Tinggal 10. Round lagi. Potong lagi. Tinggal 8. I'm going to count this. Potong lagi, tinggal 6 and so on and so forth. Sampailah acetyl-CoA. Sampailah tinggal 2 carbon. So that's the story of beta oxidation. Sangat sukar, is quite hard to break fatty acid, but it produces higher energy comparison. One molecule of fatty acid and one molecule of glucose, fatty acid produces 8 times higher energy in comparison to one molecule of glucose. Very high energy. Nak buat pun susah. Tengok nota lah macam ni dah ni. Penting lah saya tengok nota ni. Okay. The bottom line here is simple. Let's make things simple. Dia simple saja. Sebab maybe because I know this for so long kan. Macam ni je lah senang. Lambat. Macam-macam saya buat rupanya. Kita tak boleh ke potong semua sekali? Boleh kan? Mak. Potong semua sekali. Okay. Give me 1 second. Sementara you boleh minum air. Go and take your drinks before I do this. Buang. Okay. Think should okay lah kot. Cantik lah tu. This one, yang lain-lain tu we still need that. Ni yang bukan ni. Pyolysis, have you jot it down? Pyolysis tu, ni saya dah padam pula. Okay, tak apalah. Dalam nota dia kan. Alright, so dia punya konsep macam ni. So that you pun tak pening. Fatty acid, long chain hydrocarbon. It contains long chain hydrocarbon. At the end of that fatty acid tu, long chain hydrocarbon. At the end of that fatty acid tu, dia ada coenzyme A. Dia bind macam tu So what happen is that through oxidation, dia akan potong dua carbon. Let's say we have 26 carbon ataupun 28 carbon of fatty acid. Kita potong dua. How to potong dua? You have to go through 4 steps. First step, oxidation. Oxidation means this fatty acid will lose hydrogen ion, will lose electron. Okay, dia akan hilang dua benda. It will lose 2 things. Fatty acid CoA. Loss electron, loss hydrogen ion. Okay, that loss is known as oxidation. When we have oxidation, remember we must have reduction. That is why we call it redox reaction. Redox reaction kan? So pengoksidaan, penurunan. Berlaku pengoksidaan sebab apa? Pengoksidaan hilang elektron, hilang proton. Proton is also known as hydrogen ion. Proton kan? So ada benda kena terima dia. So apa? First step, FAD must accept it. FAD will accept that hydrogen ion and electron. So apa berlaku kalau dia terima hydrogen ion dan electron? What will happen? We will produce FADH2, the first energy molecule, FADH2. Then what? Dah ada FADH2, then kenapa? FADH2 will go into the electron transport system or electron transport chain so that there will be electron transfer, and at the end, it will produce ATP. You remember macam ni? Berapa banyak ATP? FADH2, 2 ATP. FADH2, 2 ATP. NADH, 3 ATP. NADH, 3 ATP. FADH2, 2 ATP. Ingat macam tu. So FADH2 akan menghasilkan 2 ATP. So apa berlaku lepas tu? Fatty acid CoA lost electron, lost hydrogen. What happened to it? Dia akan jadi struktur baru, which is known as transenol CoA. Transenol CoA. Anything happens there, tak ada apa-apa. Cuma after trans-enol-CoA, we will have another step is known as hydration. The word hydration, remember this. If you read books, you can find the word shen, T-I-O-N, shen. Hydration, oxidation. Shen mean process. Shen to process. Hydration, shen, that is process. So process of hydrating, meaning add air. Kalau dehydration, remove air. Hydration, you add in air. So when we add in air kat sini, kita akan add hydrogen ion and as well as hydroxyl ion. So these two ions will bind to trans-enol-CoA to form this structure. Hydroxy acyl CoA. Yang ni hydroxy acyl CoA. And then what's next? This hydroxy acyl CoA will go again to a process known as oxidation again. Tadi dah berlaku oxidation. Berlaku lagi another step of oxidation. This oxidation will lost electron, lost hydrogen ion, sama juga. And what happens? This time bukan FAD yang menerimanya. This time NAD plus. NAD plus. Look at the word enzyme kat sini hydroxy acyl CoA dehydrogenase. Every time you nampak enzyme, dia tulis dehydrogenase, mesti berlaku oxidation. Kena ingat tu. Here, acyl CoA dehydrogenase, meaning that ada removal of hydrogen. Every time you see dehydrogenase, a process of oxidation happens. Itu tips dia. That's a tips. Hydrogenase meaning that ada removal of hydrogen, meaning ada oxidation. Here also berlaku oxidation and then you can finally we're going to get ketoacyl CoA sebab ada ketone bodies kan, ketone group. So kat sini what happen? This is part where we're going to cut it, triolysis meaning cleave potong, cleave it and then add CoH. When we cleave this, once we cleave this, this section will become acetyl CoA. Yang panjang tadi tu, yang remaining tadi, just now if we start at 28, kita potong 2. Sekarang bila potong, the remaining will become shortened by 2 carbon. Kalau kita start 28, it's going to become 26. If we start with 18, it will become 16. If we start with 16, it will become 14. Macam tu cerita dia. So what happened to this new fatty acid CoA? Dia pusing lagi. They repeat the cycle again. Oxidation, hydration, oxidation, cleavage. Dapat 14. So again, 14. Oxidation, hydration, oxidation, cleavage. Itulah cerita dia. Sampailah we're going to produce many acetyl CoA, many FADH2 and many NADH. Depending on the bilangan carbon pada initial fatty acid. Itulah cerita dia untuk beta oxidation. That's the story of beta oxidation which originate from opor, which originate from rendang, which originate from bakso, which originate from sate. The one that you list tadi, makanan-makanan you list tadi tu, itulah origin of this energy that comes from the food yang contain lipids. Itu saja. Itulah saja ceritanya. Ada quiz ke? Ada. Jadi you just copy this code, nanti you buat